right? So direction's pretty clear. State a let statement. A little redundant. I'll take it as a typo. Make a let statement. Because statement. All right, write an equation and solve each problem algebraically. All right, so it's saying explicitly that we have to do this algebraically. All right, that's what I was saying yesterday. If it doesn't say to do it algebraically, do it any way you want. But if it says to do it algebraically, you got to do it algebraically. All right, find three consecutive integers whose sum is 300. So I wanted to just refresh your memory on integers and also what makes integers consecutive. All right, so let me get my writing implement up. So, good old number line. All right, number line extends from negative infinity to infinity. 0 smack dab in the middle. The set of integers excludes any fractions, decimals, or anything like that. All right, irrational numbers, etc. So, but we do have all the whole numbers. So 1, 2, 3, 4, 5, 6. Skip a few, get to infinity. All right, if only it worked that way. But it also has the opposite of every one of those whole numbers. All right, so -1, -2, -3, -4, -5. I went to 6, so -6. Skip a few, get to negative infinity if you're going to the left. All right. Numbers increase typically. All right. If you're progressing through the timeline, if you will, the number line, you're going from left to right. All right. But you yourself can choose the movement along the number line depending on the problem, but the standard movement is left to right. All right. So if I'm talking about consecutive integers, I might be starting off at, for example, -4. The next consecutive integer would be -3. All right. That part should be easy enough. All right. It's one after the other. What you need from this is the idea that that is a displacement of a +1 unit. All right, 1 unit of displacement in the positive direction. All right, so this is 1 unit of displacement in the positive direction. Hold on, let me shift this over. Direction. All right, we just call that +1. All right, whenever you're talking about adding, you're talking about displacement. There's a physical manifestation of addition. Subtraction would be 1 unit of displacement in the negative direction. All right, so there is the left-right movement there associated with the sign. So consecutive integers have 1 unit of displacement. All right, so we just keep that in mind. So when it says find 3 consecutive integers, my let statement would begin with just let x equal an integer. Because I started on my number line, I started with a -4. I could have started with a 20 if I wanted to. It didn't matter. As long as I didn't start with a fraction or an irrational number or something like that. All right. So let x be equal to an integer. All right. You could say the first integer if you want, but it really doesn't matter. It's just an integer, an arbitrary integer. All right. The second integer, the first consecutive integer after that given one, would have to have a 1 unit displacement. So we would say x plus 1. All right. And so that you could say the next integer. All right. So the next consecutive integer. You could say the second integer. You could say, there's a bunch of things you could say, as long as you get the idea across. All right? We want 3 consecutive integers. All right, so on my number line, I have 2 consecutive integers. I have the one we started with and the one unit away. If I want another one, I'd have to make another 1 unit of displacement. All right, so I'd be adding 1 to my initial value twice, or adding 1 to my second value just the one time. Either way, I should come up with x plus 2 as my next consecutive integer, or I could say my third consecutive integer. All right? However you want to say it, like I said. I'll say third this time. You could say, actually, it sort of makes sense to say last. I said next, so last makes more sense. All right. However you want to word it, because it said 3 consecutive integers, I have 3 consecutive integers. Whose sum means addition. So that's telling me that I'm going to add these 3 numbers together. X plus 1 plus x plus 2 is another word for equals, mathematically anyway. Can't even see the number there. It's 300. So is 300. And then we solve. All right, so I have x plus 1, x plus 2 is equal to 300. Glare is getting pretty rough. Can we kill the lights back there? Could somebody just hit those? They're right up next to the speaker. Both of them, yeah. There we go. Thanks. Maybe that's a little better. So we have 3 x's plus 1 plus 2 is 3, results in 300. Now it's just a matter of solving. So properties of equality. And we just simplified. We didn't use any properties of equality yet. I keep mentioning that because that's gonna come up. You know, like tests, the Regents exam, whatever. There's gonna be a set of questions that say, be sure to identify the properties of equality. All right, so you just got to make sure that you're aware of these things. So you don't always have to write it. You just got to know that you're doing it. So the property of equality that I'm going to use here is the subtraction property of equality, or subtraction PO. So 3x is equal to 297. Then I would subtract, or I'm sorry, divide, division property of equality, by a 3. So x would be equal to 297 divided by 3, 99. So be mindful of what the question is asking. Find 3 consecutive integers. Remember I said yesterday, x does not always mark the spot. I don't think I used those words in this class, but x doesn't always mark the spot. All right, it's part of the answer, but it's not the entire answer. Find 3 consecutive integers. I only got one of them. I have the first one, the x. I need x plus 1 and x plus 2. So my answer would involve the 99, sure, but also a 100 and a 101. All right. So that, I mean, it's fine to just box them because they said find 3 consecutive integers. You don't have to write a, I mean, I know it was presented sort of as a word problem. And I said yesterday that if it's presented in words, that the answer should be in words. But, I mean, that would be a little overkill. The 3 consecutive integers are, I mean, even I'm not looking for that. All right, on the Regents, play it safe, write out a sentence. But for me, I'll look at it and say, oh, I would have given you full credit for just writing the numbers.
So,
All right.
I'm just confused how, so 3 consecutive, so it's literally just saying like, just to add the, like, so add 1, 2, and 3 together.
Yeah.
Oh, okay. Sorry.
It gets a little trickier when you're dealing with consecutive even versus consecutive odd integers. So that's where we're getting with number 2 and 3. So 3 times the smallest of 3 consecutive even integers. So that starts getting a little dicier. But let's just focus on the 3 consecutive even integer parts. So if I'm talking about, let's say we're starting at 1. Oh, actually, that wouldn't make sense. Starting at 2. And I want 3 consecutive even integers. The next even integer after 2 would be 4. And the next one after that would be 6. So we're looking at 2 units of displacement. All right, so 2 units of displacement. So we would actually start the same way we started the previous problem. Let x be the first integer, or let x be an integer. I'm going to steal some of my writing here. All right, doesn't help you all, but it helps me. So that's a good thing, I guess. All right, so if I'm starting off at 2, the number 2, and I want to get to 4, I have to add 2. If I want to get to the next even integer, I would add another 2. All right, so I'm going to start off at an integer, some integer that I call x. I want to get to the next even integer. I'm just going to add 2 to my x. If I want to get to the next even integer after that, I would just add another 2. So that gets me to 4. Now we're looking at 3 consecutive even integers, so we're good. So I use my whole integer, next, and last. You could say first, second, third. There's a bunch of different ways that you can write it. If you have 4, then you're definitely going to write it a little bit differently, but it's really up to you as long as you get the idea across. All right? And as long as you define your variables in some meaningful way. So now we have our variables set up. What we have to do is write the equation. 3 times the smallest. Well, each of these involve adding something to x. So that means that x has to be the smallest. All right, so I'll just make a little note of that. 3 times x is 6 more than twice the largest. Well, the x plus 4 is the one that has the most added to it. Even if x were a negative number, you're still adding more to that last integer than you are to the first or the middle one. All right? So the largest has to be the x plus 4. So, like if you're not able to just look at the words and come up with the equation right away, then make little notes. That tends to be helpful. So now I would read it as 3 times x is 3 times x is means equals 6 more than 6 plus twice the largest. Twice the largest. The largest is a binomial x plus 4, so I want to have that in parentheses. And so from there, I'd look for my integers by solving for x, algebraically, because the direction's set to do that. And then from there, I would just have to make sure that I've actually answered the question. All right, can't forget to do that. All right, so I'm going to distribute the 2. So I'll have 3x equals 6 plus 2 times x is 2x. 2 times 4 is 8. I'm going to combine some like terms. 3x is equal to, I have a 6 and an 8 on the right-hand side. Still not using properties of equality yet. I'm just combining like terms. All right, so 6 plus 8 is 14. So 14 plus 2x. I want to get the x's grouped together so I can isolate x. So I'll use a property of equality, subtraction, to bring the 2x over. Left-hand side, I got an x. 3 minus 2 is 1, so 1x is 14. So that's the first of the 3 consecutive even integers. So 14 is my smallest. Add 2 to that. That's what it says right here. We defined it that way. 16 would be my second. Add 4 to my first number. 18 would be my third consecutive even integer. All right. So, you know, the setup is the most important part, obviously. Coming up with that equation, because you saw, I mean, I'm recording this, so if I play back the recording, you'll see the time stamps and everything. But the bottom line is, it took a while for me to explain everything up to and including developing the equation. It took like a minute to solve the equation. Right? So, and that's just, that wasn't me rushing it. That's just the nature of it. It was not, neither of the equations were overly challenging. The setup was a little bit more challenging. So we'll do one more because this is the one that tends to confuse people the most. The case of consecutive odd integers. Now this one says find 4 consecutive odd integers. All right, so now we're jazzing it up a little bit. All right, but we'll talk about what consecutive odd integers mean. I'm gonna draw the number line again, and by draw it I mean I'm just gonna copy and paste it, and then erase some stuff that I don't need. Also, it'll help me avoid having to go back and forth. All right, so I don't need this stuff anymore. We're not dealing with consecutive in general. Get out of here. Yeah, I can live without the tick marks. Just put them right back in. There we go. All right. Now, these were the consecutive even integers. All right, I'll just move it up a little bit so you can see. These are consecutive even. Two units of displacement, we had it going from 2 to 4 to 6, right? For example. All right, so let's say I want to have consecutive odd. And I want to start it at -3. I already have it highlighted, so why not, right? So I'll start it at -3. If I want to go to the next odd number, I'd still have to make 2 units of displacement. I'd still have to add 2. All right. To get from -3 to -1, it's a movement of 2 units. All right. It's still 2 units of displacement. So consecutive odd. Two units of displacement. Units. I crossed the I there for some reason. Let me shrink that down a smidge. There we go. All right, which involves a +2. So if I want to get to the next one, I'd have to do another +2. All right, so what we get from that is that the setup is going to be pretty much the same. Except the only difference is we have 4 consecutive integers here. All right, so because people get confused by that because they think all right, consecutive even integers will do x plus 2, x plus 4, but for consecutive odd, we'll do x plus 1, x plus 3, x plus 5, because they think odd. Let's just add odd numbers. But that's not the case. It's still a 2-unit movement, all right? So we can't lose sight of that. That's really what I'm getting at. Long story short. Too late. Probably could write this stuff out quicker, but I'm choosing to copy and paste again. Here we are. I got a floating G out of it. Ah, jeez. Going crazy here. Copy. Paste. So x plus 2 to get to the second consecutive odd integer. X plus 4 to get to the next consecutive odd integer. Let's get rid of all these evens here. The danger of copy paste, of course. The last one, I'd have to go a little bit further. All right, so I went 3 consecutive odd integers. I need to go one more, so x plus 6. All right. So those would be my 4 consecutive odd integers. The reason why, so historically, people have written first consecutive odd integer, second, third, fourth. I've taken off so many points over the years for people writing the wrong integer in the wrong place. So they'll write consecutive, like the second consecutive odd integer in the place of the third one. And I don't want to do that. So I just say integer, next, and get to your last and call it a day. But it's up to you. If you want to write first, second, third, fourth, that's fine too. Was there a question floating out there?
Yeah. So if we had this question on the test, would we have to draw the test out of the line?
No, you don't have to draw that. That's just so you can understand the concept. Yeah. All right. So we have the setup in terms of the let statements. Find the first 4 so that the sum of the first 3 integers, okay, so we'll start with that. The sum of the first 3 integers, these got to be the first 3. So, and they're saying sum. So x plus 2 plus x plus 4 exceeds the 4th by 18. All right, so that the language there can be a little tricky. What do they mean by exceed? Well, if I say that my age exceeds your age by, well, they said 18, I'll go by 18, that's being generous. But if I say my age exceeds your age by 18, I'm saying that my age is 18 more than your age. All right? So if they're saying, oh, and by the way, that just means just take your age, add 18 to it, and you'll get mine. Or take my age, subtract 18 from it, and we'll get yours. Either way, it'll work. All right. So if you start to conceptualize what the terminology is really telling you to do, everything starts kind of playing out a little bit nicer. All right. So if I tell you that you're exceeding the speed limit, you're driving, you're exceeding the speed limit by 20 miles an hour. What that means, it means 2 things. Take the speed limit, add 20 to it, you get your speed. Take your speed, subtract 20 from it, you get the speed limit. All right, so like I said, either way. So what we could do here is 2 possible equations. We can take this, subtract 18 from it.
What about the x plus 6?
Well, that's the thing. It exceeds the 4th by 18, so we're going to set this equal to x plus 6. Or we can take the first 3 values, add them together, and set that equal to the 4th value plus 18. Oops, a little off the page there. When it's just math, it seems to be all right. When we throw in language, that's when people start to have a little bit of issues. You know, it's tricky because these questions, you know, I mean, as much as it pains me to say, these questions are generally designed for you to stumble on the language. You know, they want to trick you up with the exceed part of it. They want you, they being the Regents people, they want you to put that 18 on the wrong side. All right? That's just, it's as simple as that. It's mean, but that's what they do. All right? They're mean. So, we'll solve them both. Why not, right? We'll give some room here. So for the first one, we have some like terms. We get 3x's. So just stay on the left for a second here. So 3 of those x's. 2 plus 4 is 6, minus 18 is negative 12. Right-hand side is x plus 6. Question?
Why would the x plus 6 be on the opposite of the equal sign and not with all the other numbers?
Because it's saying that it's exceeding that fourth value being the x plus 6.
Okay, thank you.
Yeah, no problem. So I'm going to subtract the x, subtraction property of equality. I'm going to add the 12, addition property of equality. Simultaneously, nothing wrong with that. Do it separately if you want. So 2x is equal to, we got 18 here. Now, if our result here gives us something that's not an odd integer, we should start getting nervous about it, but in this case it's going to give us an odd integer, so we're good. So divide by 2, and you get x equals 9. Alternatively, if you wanted to, you could have worked with the other variation of the equation, combining our like terms. On the left, we get 3x plus 6. On the right, we get x plus 24. It doesn't take too long before you realize you're going to get to the same step in the process, because we'll subtract the x, subtraction property of equality. We'll subtract the 6, also subtraction property of equality. We'll have 2x is equal to 18, which brings us to this step here, which brings us to the solution x equals 9. Or part of the solution anyway, because we need all 4 consecutive integers. Most of the time anyway. Let me reread the question. Sometimes they only want you to state the smallest or the middle one. Find 4 consecutive odd integers. We got the smallest, the x equals 9. Counting off odds isn't difficult, so we would say, okay, I need 4 of them. 9, 11, 13, 15. Aw. Oh, there we go. It's like a trapezoid. Hold on.
So you're basically just finding like, oh, what are 3 odd numbers that, like 2 consecutive numbers that when added together equal a certain number?
Yeah, that form a certain relationship, yeah.
Okay.
Exactly. But you can see how, I mean, they could get a little intense,
Oh, yeah.
but it all comes down to the setup. I mean, I think most people agree that once you get the equation, it's fine. So the time should be spent on making sure you understand where the equation's coming from, because after that, solving it shouldn't be as much of a problem. All right.